Hi, my name is Roberto Trotta. I'm a lecturer in astrophysics at Imperial College London. At Imperial, we have been running a series of public debates discussing the big questions in astrophysics and fundamental physics. And today, after a huge success asking questions about the existence of parallel universes, the origin of the universe and the existence of God, or the existence of dark energy, today we continue this series discussing whether human spaceflight is fundamentally important or not for humankind's future. And discussing this issue are here with me Dr. Ian Crawford from Birkbeck College and Dr. Dave Clements. So Ian, I would like to start with you. Why do you think that human spaceflight is important for humankind?
Oh, I think human spaceflight is vastly important for humankind. But as I understand our debate, we're here to discuss whether it's scientifically important or not.
Absolutely.
So there are many dimensions to this, in addition to the scientific issue, that we're concentrating on. Scientifically, I would argue that human spaceflight contributes in three broad areas. It contributes to studies in the life sciences and physical sciences in the microgravity environment, including human physiology and medicine, which absolutely requires people because the subjects are people of that research. The infrastructure of human spaceflight has capabilities for the maintenance and maintaining the operatorability and upgrading astronomical facilities, of which the prime example is the 5 upgrades that have been done to the Hubble Space Telescope. And finally, I will argue that human spaceflight contributes to the exploration of planetary surfaces, where astronauts on the ground, as pioneered during the Apollo program, have shown themselves to be vastly more versatile than the small-scale rovers which have been used to date.
So 3 reasons why human spaceflight is scientifically important. Dave, what do you think?
Human spaceflight is immensely expensive, and the scientific returns that have been achieved for that vast expense have been pretty minimal. If you compare what's been done since Apollo by robotic missions, we've explored every planet of the solar system. We've looked at every part of the electromagnetic spectrum that you can reach from Earth orbit, and we've plumbed the solar magnetic system, looking at plasmas in the solar system to a great extent. And all of that has been done for substantially less money than has been spent on the manned spaceflight program, which has achieved scientifically relatively little.
So more science for your money.
I would argue we haven't explored the solar system at all. What's being done to date, very successfully robotically, is the initial reconnaissance of most of the planets in the solar system. What we'll find, I think we're already beginning to find, is that we're going to rapidly approaching the limitations of robotic exploration. So they've achieved the initial reconnaissances, and that's great. But when it comes to understanding planets in greater detail, then I think we're going to need boots on the ground wherever possible. This is, after all, the way we explore our own planet.
I beg to differ with that. The only places you can put boots on the ground in the solar system, realistically, for the foreseeable future, are the Moon, Earth-crossing asteroids, and just about at the very, very limits of what's practically possible, Mars.
That's absolutely correct. I don't think we can disagree with that. Though within the next several decades, those are indeed the only localities in the solar system that human beings can realistically visit. My point will be that for the exploration of those bodies, and remember, we're only here concentrating on the planetary science strand. There are lurking in the background the human physiology and the astronomical instrument strands, but just within the planetary science strand of human exploration, my argument will be that boots on the ground on those bodies will yield vastly more knowledge of them and their history than has been achieved, can be in principle achieved with small-scale robotic missions.
But for the money you spend to send men to Mars, and women, of course, you will be able to send hundreds of considerably more advanced robots to the same place.
So boots on the ground versus robotic probes.
Yes.
And debate is going to show whose side will be actually supported by the public. Thank you very much.
My name is Paul Nandra, and I'm from the Astrophysics Group, and I've just chaired the debate that we've just had about human spaceflight, whether it's more about science or more about spectacle. We had a really lively debate. I thought it was a great debate. In fact, it's still going on right beside me. They're still arguing with each other, and probably will be for the rest of the night. A lot of people thought that human spaceflight was actually more about spectacle, because I always felt that people associated human spaceflight quite intimately with science. So I was surprised about how many people were skeptical about its value for science. We did a vote at the end after the debate. More people, again, were swayed over to the idea that human spaceflight was really more about spectacle, perhaps about inspiration, but not strictly speaking an endeavor that you do to enhance, primarily to enhance science. Both speakers made some excellent points during the debates. I think they really got their points across, and people appreciated them. And I could see people changing their minds as they discussed the points. I think a lot of people ended up being convinced that if you want to do purely science, you really don't need to send human beings into space, and you can do things with robots or remote control and telescopes out there. So I really enjoyed the debate, and it made me think about a lot of new things, and I think it did for the audience too.